In this video, we're going to discuss switch security. And obviously there are entire courses and entire books that are written on Cisco switch security. For the ICND1 exam for the CCENT, all you have to worry about for switch security is Telnet versus SSH. Now, if you've dealt with networks for any period of time, you know what Telnet is. It's that wonderful protocol that lets you connect to devices remotely so you don't have to run around your network with a console cable plugging into all of your routers and switches or firewalls or refrigerators or whatever is out there that supports networking. However, Telnet is quite insecure, as we'll demonstrate here with our packet capture. We love Wireshark in this business, and so let's look at a Telnet login to a switch. And I've included this Telnet login as well as the SSH login file that we're going to look at next as part of the work files for this course. So I'll go ahead and expand the Telnet window down here and shrink this down so you can see everything. This is a Telnet session between a workstation and a switch in my lab network. So as you can see, I initiate the Telnet connection, and we get the login banner, have a wonderful day, and I'm asked for the username. In this case, I will send my information, FRED, so that's the username. I hit enter. It asks me for the password, and since it doesn't echo the password back, I only get one character in the Telnet traffic for the password. So there's FRED. And there's my lab switch 1 prompt coming back from the switch, so we can already know that our Telnet password is Fred. Obviously, that's a very simple password, but it could be any complex password in the world. It's out there on plain text on the network. So now we're going to enable. There's our enable password, CISCO, enter. There's the enable prompt. We're going to show run. And there's the running configuration of the switch just spit out on the network in plain text for anybody to happen to grab off. Obviously, Telnet will do in a pinch, but it is not secure by any stretch of the imagination. On the other hand, let's go and look at SSH. Now, this is the same switch. You can see it's the same IP addresses, and we'll shrink this down here and open up the SSH protocol window. And you can see that we connect here. And once we negotiate the keys and whatnot, you can see that all the data after that is encrypted. You could, in theory, decrypt that, but by the time you decrypted it, the data would be useless because it would be several years old by the time you decrypted it, if you set SSH up correctly. So as you can see, SSH is pretty much required if you're going to keep your network traffic, your administrative traffic to your switches secure. So how do we do that? There are a few steps to enable SSH on a switch, and we'll go through all of them. First off, we have to set a username and a password that's permitted to log in on the switch. So we'll go back here to our handy-dandy lab switch. We're already enabled, so we'll go into Config T. And the first thing we have to do is set up a username, because obviously we were not prompted for a username when we telnetted in, and SSH requires a username and password. It's just integral to the protocol. You can't log in without one, without a username at least. So let's use the username command, user, and hit question mark. We are prompted for the username. In this case, I'll keep it consistent with my test switch, and I'll give the user as Fred. We have several subcommands after we specify the username. The two we're going to be using is privilege and password. So the first thing I'm going to do is say privilege, hit question mark, and we're given a privilege level between 0 and 15. 0 is the most restrictive. It's just the basic login prompt. 15 is enable mode. So you have granular control over how much privilege each user has on your network device. In this case, we're going to say Fred is an administrator, so we'll give him privilege 15. After that, we can set the password, so we'll do password. And I'm going to specify password 0, even though it defaults to unencrypted, just like with the Telnet and console passwords. In this case, we will keep it consistent, keep his password as Fred. So now most people say, well, I've set a username and password. I should just be able to log in using that username and password. Well, let's test that theory. So we'll connect to this switch via Telnet. So once we connect, we're just prompted for the password. Why weren't we asked for the username? Well, we'll enter Fred as the password. Obviously, Fred's not the password. The actual password is password 1, I believe. Yes, password 1 for Telnet. And we're dumped into user exec mode. So we'll go ahead and exit from this guy. So there is obviously another step to be done with the VTY lines. So let's go back into config T. We'll do line VTY 015. And the magic sauce, if you will, in this is in the login command. You remember we did login and question mark. We have the option for a local password checking. And again, if we had a Radius server configured with the AAA server commands, then you'd have more commands than local in here. In this case, we'll do login local, and we'll write the config just to be on the safe side. So now we should get prompted for our username and password. So we hit connect. Now we're prompted for our username, FRED, password, FRED. And since he's a privileged 15 user, he's dropped right into the privileged exec mode. No need to actually enable to get access. So that's well and good. Does SSH work at this point? Well, we have an SSH key already, just by virtue of running through the initial setup. However, if you had to set it up on a switch that was already running, you go into config T, and the actual command is crypto key generate, and we're going to generate an RSA key. I'm sorry, we have to specify a domain first. I can't believe I forgot that. So we'll do IP domain name, and we'll do test.local. Now we'll do crypto key generate RSA. How many bits in the modulus? We'll just leave it as the default as 512. Again, that's good enough. Some administrators specify 1024, 768, or 2048. We'll just leave it as the default. So now it's generating 512-bit RSA keys, and so now we can actually do IPSSH version 2 to specify we only want to use version 2 and not the older, more insecure version 1 SSH protocol. And so now let's see if SSH works. So let's connect here with 2960 SSH. We'll give the username of Fred, the password of Fred, and there we are. We're now connected with SSH. However, we're still connected with Telnet. Let's go out here and write the config, again, just to be on the safe side. And if we exit Telnet, we should still actually be able to connect with Telnet. So let's do 2960 Telnet. So we still accept Telnet connections to our switch. How do we turn that off? Well, again, it's part of the line configuration here. And it's a command we haven't used so far, so we'll go into config T line VTY 015, and it's the transport command. So transport input, define which protocols to use when connecting to the terminal server being this switch, and we have the options for all, none, SSH, or Telnet. In this case, we're only going to do transport input SSH, and go out and write the config. So now let's try to connect via Telnet, and let's see what happens. So we do 2960 Telnet. The remote system refused the connection because we are not permitting Telnet connections through this guy. However, we can still connect with SSH just as a test. We'll do Fred, and there we are. So now we have secured our switch, at least as far as ICND1 is concerned. And that concludes our discussion of switch security.